Hello and welcome to this video on Bivariate statistics. This time we're going to talk about moving means. We are in the part that includes fitting and Myers lines and least square method lines and so on. So I will make several videos on these subjects. First, the purpose of moving means we don't want to perform a fitting that is a linear or a curly fitting on the cloud, but just to calculate means. And let's see the method and what is the real purpose here. We are in a special case, and let's take the example of our exercise 6 that shows varying turnover of a company through time. So vertically, you've got a turnover, and horizontally, trimesters, one after the other. One, two, three, four. So you've got a total 16 trimesters, and so 4 years. This company has a seasonal activity, and let's consider that the first point consists in winter, the second one the spring, summer, autumn, and then winter, spring, summer, autumn, and so on. Okay. In the case of a time series with big variations of the value, we are confronted to try to guess the evolution of the average turnover. Moving means help us for that. How do they work? Well, they can calculate an average trimestrial turnover thanks to four values. Okay, you've got a periodic function here, a periodic turnover each year, so by four values, values 4 by 4. If you calculated only the average turnover for the first year and then for the second one, for the third one, for the fourth one, you would only get 4 points. So in order to guess a trend, it's a bit too little. Moving means allow us to calculate average turnovers for periods of 1 year, but numerous turnovers. How do we do? We have to calculate the average turnover of the four first points, to the first four here, and then to slide from one trimester to the right, and then to calculate the turnover on average with the points number 2, 3, 4, 5, and then the average turnover of the points 3, 4, 5, 6, and so on and so on and so on. So you now understand the title moving means. Well, the result will be to smooth this kind of curve. You will observe very little variations in terms of average turnovers, and we can do a bit better than that by taking 5 points and not four. Well, let's consider to calculate the average turnover of the winter, spring, summer, autumn, and then winter. Of course, if you count winter twice or two winters of two different years, it's a bit too big, okay, compared to spring, autumn, and summer. So you have to put coefficients on winters. So to put a coefficient 1/2 for the first winter and 1/2 for the second one, and then calculate the average value of the 5 points, with of course coefficients 1 for the three intermediate points. If you do so, and then slide of one trimester to the right, and so on and so on, you will smooth a little better your first curve, your initial one. So that's the rule of moving means. If your period is 4 points, that appears here, just calculate means of 5 points. So our initial values that can be read, okay, vertically on the graph. There is not a big accuracy here, but you can consider that they can be read. Let's display them. No, well, I didn't display them. That's a pity, but whatever. You will calculate the first turnover times 0.5 plus the second one, plus the third one, plus the fourth one, plus the fifth one times zero point 0.5. Overall divided by 4, of course, the sum of the coefficients. 0 0.5 plus 1 plus 1 plus 1 plus 0.5. The first moving mean equals 39.75. The second one, taking into account the 5 following points, has a mean of 39.875, and so on and so on and so on. This way, and let's graph it as I did earlier, you can see on the graph and in the chart a little evolution, quite constant, okay? So you can see a trend with the average trimestrial turnover that wasn't be easy to see if you considered your initial big waves. Okay, so that's the logic of moving means, and that's the advantage of moving means. Well, I hope it helped you a little to understand what moving means are. Don't forget to add a point to the period that is interesting for you in some exercise. Okay, to add a point and to consider a half coefficient on the two extreme points of your calculation. Thank you and bye, and see you to the next video with Myers lines.